My model for the Hadley cell. So at ITCZ, the sun heats the moist tropical air, which is around here, as it causes it to rise. So the sun here, and the heat begins, or the water moisture begins to rise into heat, the heated air. The rising air experiences adiabatic cooling when it gets to around here, which causes water vapor to condense into rain. So it heats up, or it cools down once it gets to this point, and then there's rainfall because of the precipitation. The condensation of water vapor produces latent heat release, which causes air to expand and rise further up into the atmosphere. So, from here, the air keeps getting hotter and rises more and more until it gets to this point up here where it meets the cool, dry air. The warm rising air then begins to displace the cool dry air, so let's forget about that for a second, and pushes the air to the north, to the north and south. So this is cooler air, it's being pushed to the north and to the south. The cool, dry air then begins to sink. As you can see, it's in a downward motion. It begins to sink down to the 30 degrees north and the 30 degrees south. To this point right here, it begins to sink. It sinks on both sides. I just don't have an extra. Yeah, I can put that here. It begins to sink. Because of the adiabatic heating. It reaches Earth's surface as warm, dry heat because of the heat, the adiabatic heating. So it enters back into the, near the equator. So then when it gets back up here, it picks up moisture once again, and the process starts all over again where the heat rises again.